Derivatives of logarithmic functions. Let's say our f of x is equal to logarithm base a to the ux. Okay, so its derivative is equal to the derivative of u over u times logarithm base a to the e. So let's look at this example. Here we have f of x is equal to logarithm base 2 to the 3x plus 3. So what is the derivative of f of x? So let's apply this rule here. So it says the derivative of f of x is equal to the derivative of u, which is here, it's 3x plus 3, right? So what's its derivative? It's equal to 3 over, we write this as it is here, so it's 3x plus 3 times logarithm base a. So here our a is equal to 2 to the 3x plus 2, but here we write e, right? So this is our formula, it's e. So the derivative of f of x is equal to 3 over 3x plus 3 times logarithm base 2 to the e. Now let's see how we solve problems when we have natural logarithm. So let's say our f of x is equal to natural log of ux. Okay, so its derivative is equal to the derivative of u over u. Okay, let's look at this example. For example, here we have ln of x squared minus 5x is equal to y. So what's this derivative? So as you can see here in this formula, we will take the derivative of this part and then we will divide it by the original expression. So it will be the derivative of u over u, which is equal to, what is its derivative? It's 2x minus 5 over u, it's x squared minus 5x. You can see this is very simple and easy to remember. So we have learned two different formulas for logarithmic functions so far. So let's look at these two examples. So here we have y is equal to logarithm x squared minus 5x, and here we have y is equal to natural log of sine x. Okay, so how do we take the derivative of this one? It is equal to the derivative of the inside of this parenthesis, right? So this is equal to, right, like this, the derivative of y is equal to, this is 2x minus 5 over x squared minus 5x times logarithm e, right? This is our formula. When you don't have the base, we accept this base as 10, so we don't need to write here. So let's look at this one. Here we have y is equal to natural log of sine x. So this is equal to the derivative of u over u, right? Which is equal to here. This is equal to u, the derivative of u, which is sine. Its derivative is cosine x. So it's cosine x over sine x, right? So actually I can also write here logarithm base e to the e, but why I don't write it? Because this is equal to 1. Okay, since this is a natural log or logarithm function, I don't need to write this one. Okay, since this is equal to 1, the derivative of natural logarithms are equal to the derivative of u over u. And since this one is not the natural logarithm, that's why I need to write this logarithm e here. Okay, so let's continue with this example. Here we have y is equal to the natural log of x cubed minus x squared to the power of 2. And what is the derivative of this function? So as we said before, we can write also this expression as ln x cubed minus x squared to the power of 2. Okay, so let's take its derivative. So the derivative of y is equal to, I put this 2 in front of this parenthesis, so it's 2 ln x cubed minus x squared, okay, to the power of 1, because it's 2 minus 1 is equal to 1, times, now I need to take the derivative of the inside of this parenthesis, which is equal to the derivative of this. This is 3x squared minus 2x over this one as it is. I write this down as it is. It's x cubed minus x squared. Derivatives of exponential functions. So here we have f of x is equal to a to the power of u of x. So as you can see here, this function is given as an exponent of a constant. Okay, that function is called as an exponential function. So there is no function on the base, so the function is here as an exponent. So how we take its derivative? The derivative of this function is equal to the derivative of u, which is this function, times a to the power of ux times ln a. So let's look at this example. Here we have f of x is equal to 4 to the power of 3x squared. So what is its derivative? So how we take its derivative? The derivative of f of x is equal to, so the derivative of u, which is here, is 3x squared, right? So what is its derivative? It's equal to 6x times a to the power of u of x. So we'll write the same here. It's 4 to the power of 3x squared times natural logarithm of a, which is here, it's equal to, our a is equal to 4, so it will be equal to ln 4. Now let's continue with this rule. Here we have y is equal to e to the power of u of x. So its derivative is equal to the derivative of u times e to the power of u. Okay, so this formula is actually coming. This formula is comes from exponential functions, but in that formula we have ln a. Right, so here our a is equal to e. So since ln e is equal to 1, we don't need to write this one here. Okay, that's why formula is like this. So let's look at this example. Here we have y is equal to e to the power of x squared plus x. So what's its derivative? Let's apply our formula. So here it's the derivative of u, which is equal to 2x plus 1, okay, times e to the power of u. So here it's e to the power of x squared plus x. So let's look at our second example. Here we have y is equal to e to the power of 3x times cosine 5x. So what is the derivative of y? So we will apply the product rule here. So the derivative of the first one, which is equal to 3, right? The derivative of 3x, it's equal to 3 times e to the power of 3x times the second one, cosine 5x. And then it's plus, but since the derivative of cosine is minus sine x, I put here minus, okay? So it's minus sine 5x, and also I should take the derivative of this 5x, which is equal to 5 times the first one, it's e to the power of 3x. Now let's look at this function. Here we have f of x is equal to g of x to the power of h of x. So when we have two functions like here, one is as a base and another one is an exponent, we need to use logarithm to take its derivative. Okay, so to find its derivative, first we take natural logarithm of both sides. Let's do that. So when I take the natural logarithm of both sides, it will be ln f of x, which is equal to natural logarithm of g of x to the power of h of x. Okay, so from the logarithm rules, I know that ln a to the power of b, I can write this as b times ln a. Okay, so here this hx, I can put this in front of this natural log. So let's do that. So ln f of x is equal to h of x times natural log of g of x. Okay, so after this we can take derivatives of both sides. So let's do that. So what is the derivative of a natural logarithm function? It's equal to, let's remember here, let's say it's ln x, it's equal to the derivative of x over x, right? So here it will be the derivative of f of x over f of x, which is equal to, here we will apply the product rule. The derivative of the first one, it's the derivative of h of x times the second one, natural log of g of x, plus the derivative of the second one, which is here equal to the derivative of g of x over g of x times the first one, h of x. Okay, so I know it looks complicated, but you need to understand the logic behind it. After that it will be easier to apply. For example, here we have y is equal to x squared minus 1 to the power of sine x. So what is the derivative of y? As you can see here we have two different functions. One is as a base, another one is as an exponent. So we will apply the same rule. So first we will take natural logarithm of both sides. Okay, so this will become natural log of y, which is equal to natural log of x squared minus 1 to the power of sine x. Okay, so after that, as we said before, I can put this sine x in front of this ln function. So let's do that. Here we will have ln y is equal to sine x times natural logarithm of x squared minus 1. Okay, so after this we can take derivative of both sides. So this will be ln y, its derivative is equal to the derivative of y over y, which is equal to, here we will have we will apply the product rule here. So here sine x times ln x squared minus 1, right? So the derivative of the first one, it is, what is the derivative of sine x? It's equal to cosine x, right? It's cosine x times the second one, natural logarithm of x squared minus 1, plus the logarithm, the derivative of the second one. So here we have natural log of x squared minus 1, and its derivative is equal to the derivative of inside of this parenthesis, it's 2x over x squared minus 1 times the first one, sine x. Okay, so this is how you should do in this kind of questions. After that, we are not over yet, because it's asked that what is the derivative of y. So after that we will do cross multiplication here. So from here we will get the derivative of y as cosine x times natural logarithm of x squared minus 1 plus 2x over x squared minus 1 times sine x, and times, we should multiply by y, which is equal to this one, and this is x squared minus 1 to the power of sine x.